Now that we've talked about what the solutions for a linear system look like, let's talk about how to find them. The first method we're going to use is the substitution method. There are three basic steps in the substitution method. The first step is to solve for a variable. We're going to pick one of the equations and one of the variables and solve for this. So we might want to solve the second equation for x or the first equation for y. If at all possible, I highly suggest picking an equation and variable that has a coefficient of either 1 or -1, because this is going to avoid introducing unnecessary fractions. The second step is to substitute. We've solved, let's say, the first equation for x, so we're going to stick this into the second equation for x. So we're going to use what we found in number 1 to stick into our other equation. After that, we just have a single equation in one variable, and we can solve for that variable. The third step is back substitute. We're going to substitute the value we just found in step 2 into the equation we found in step 1 and solve for the remaining variable. So let's look at some examples on how this works. The first linear system I'm going to look at is x plus 3y equal to 7 and -2x plus 5y equal to -3. The first step said to solve for a variable. And like I said, we really want things that have a coefficient of 1. So I'm going to solve my first equation for x. In order to do this, I want to get x on one side by itself. So I'm going to start by subtracting 3y from both sides, which gives me x is equal to 7 minus 3y. So now I have x on one side by itself, which is exactly what I wanted. So I've done step 1. And now we move to step 2. Step 2 wanted me to substitute what I just found into my other equation. The second equation said -2x, which we're changing to 7 minus 3y, plus 5y is equal to -3. And now I can just solve this equation. We start by getting rid of our parentheses. Multiplying out gives us -14 plus 6y plus 5y equal to -3. I can then combine like terms to get -14 plus 11y is equal to -3. I then add 14 to both sides. That leaves me with 11y is equal to 11. I then divide both sides by 11, which gives me y is equal to 1. So I have my first variable. We can now move to step 3, which wanted me to back substitute. It wants me to take the thing I found in number 1 and the thing I found in number 2 and combine them. From step 1, I got that x is equal to 7 minus 3y. Step 2 told me that y is equal to 1, so I'm going to stick that in. That gives me x is equal to 7 minus 3 times 1. That's the same thing as 7 minus 3, which is equal to 4. So I now have my solution, which is 4, 1. And we can double check this. You can stick 4 in for x and 1 for y into each of these equations. You can also graph these two lines and see that they do intersect at the point 4, 1. Let's do one more example. This time I have 2x minus 2y equal to 8 and 4x plus y equal to 1. This time I'm going to solve my second equation for y. And this is because the coefficient of y in the second equation is 1, which means I don't have the chance of introducing fractions. So we solve this equation by subtracting 4x from both sides, which gives us that y is equal to 1 minus 4x. Step 2 then wanted me to use that to substitute into my other equation, my first equation. The equation said 2x minus 2y, which we know is 1 minus 4x, is equal to 8. Distributing my parentheses gives me 2x minus 2 plus 8x is equal to 8. And then combining like terms gives me 10x minus 2 is equal to 8. We then add 2 to both sides, which gives me that 10x is equal to 10. Finally, we divide both sides by 10 to get that x is equal to 1. So now we have x, and we can substitute that in to find y. Step 1 gave us that y is equal to 1 minus 4x. So I have y is equal to 1 minus 4 times 1, since x is equal to 1. We then have 1 minus 4, which is equal to negative 3. So I now have my solution, which is 1, negative 3. And once again, you can check this by sticking it into my original equations and making sure it works, or by graphing the two lines and showing that they do intersect at the point 1, negative 3.